Today we are going to be looking at solid mensuration. Solids are three-dimensional objects. For example, cubes, cuboids, cylinders, cones, pyramids, and prisms. We shall look at their areas. We shall also look at their volumes. Solid mensuration. Solids are three-dimensional shapes. They have length, breadth, and height. For example, cubes, cuboids, cylinder, pyramids, cone, sphere, hemisphere, and prisms. We shall be looking at the surface area and volume of common solids. Let's take the first case, the cube. And here is a description or a diagram representing a cube. Example of cube is the sugar that we use in our homes, or the Maggi cubes that we also use in cooking. Here is a description of a cube. The dimensions of the cube are all equal. That is to say, the length, the breadth, and the height are equal. L here represents the length. Let's look at A, the total surface area. You know, the cube has 6 faces of equal dimension. And the area of a face is length times length, which is L squared. The 6 faces become 6L squared. That will give you the total surface area of the cube. Then we look at the volume. To find the volume, it is the base area times the height of the solid. The base area times the height. And where is the base area? L times L. This is the base area. Then the height is also L. So that is why we have L times L times L equal to L cube. That gives you the volume of a cube. The second solid we want to consider is cuboids. Here is the diagram representing a cuboid. An example of cuboids: the matchbox, the chalk box, and even boxes that we put things in our homes. Some of them are of this shape, and they are called cuboids. Even the textbook that you have with you is also an example of a cuboid, because it has length represented by L here, and breadth represented by B here, and height represented by H. Sometimes the height can also be represented or said to be the depth, depending on what you are measuring in the cuboid. Either you are measuring the depth of water, or you are measuring something different from the depth, or you are calculating just the volume of the entire cuboid. Now, we have A, the total surface area of the cuboid. The total surface area. We have here 2L times B. L here is your length and B is your breadth. You will realize that a cuboid has 6 faces, and a pair of faces are identical. And that is why we are multiplying by 2. The same thing here, length times height multiplied by 2, and then breadth times height multiplied by 2. The sum of them gives you the total surface area of the cuboid. Then we will also look at the volume. The volume here is the base area times the height, and the base area is length times breadth, and then times the height, which simplifies to length times breadth times height. With this one, we can find the total surface area and then the volume of a cuboid. Now let's look at triangular prism. The third case, triangular prism. Here is a triangular prism. Look at the diagram. A triangular prism has two triangular faces and three rectangular faces. Two triangular faces and three rectangular faces. And of course, the triangular faces are right angled. The triangular faces are right angled. So they are right angled triangles. Now we are going to concern ourselves more with the volume of the triangular prism. We find the base area, which is the dotted shape, the triangle that I have dotted here now. So we find the area of this triangle and multiply by the height of the prism. So base area times the height and equal to half AB times H equal to half ABH. Remember, or you recall, that the formula for finding the area of a triangle is half of the base times the height. And we can also find the area. You find the total area of this prism by taking each of the plane shapes that has formed the triangular prism. For example, you can find the area of this triangle, multiply it by 2 to give you the area of the two triangles. Then you find the area of the other rectangular faces, add them together, and that will give you the total surface area of the triangular prism. We take a look at the next solid, and that is a cylinder. A cylinder is of this shape. It has radius, it has also the height. And from one point to the other here is the diameter. We have example of cylinder in our everyday activities, or let's say everyday properties in the home. A milk cup, a tomatoes cup, and of course a Bonvita cup, and a drum. All are examples of a cylinder. Now, there is what we call the net of a cylinder. When you talk about the net of a cylinder, it's a situation where you cut out the surfaces that have made the cylinder. And these are the bottom and the top. When you cut it out, maybe with your thin cutter, you will have a circular face like this. While the body that is folded, and if you cut it down and stretch it out, you will have this stretch. You will now see that this is a rectangle, this is a circle, and this is a circle. The height of the rectangle is the same thing as the height of the cylinder. And the stretch is the circumference of that cylinder. And you know, to measure the circumference, we use the formula 2 pi r. That is why this stretch is 2 pi r and the height is h. And of course we have the circle that has the radius, and this circle that also has its radius, the same radius. So this one is the net of a cylinder. So the net of a cylinder is made up of two circles and a rectangle. Now let's look at the areas. We will consider first the curved surface area. And the curved surface area is that curved body that you slice and stretch out to form a rectangle. And 2 pi r becomes the length of the rectangle, while h is the breadth of the rectangle. And to find the area of that surface, you multiply the length by the breadth. That is why we have 2 pi r times h. B. Roman figure 1. Total surface area. Meaning the area of the base, the area of the top, which are both circular, and then the area of the body, the curved body, which will stretch out to form a rectangle. So the total surface area will be the stretched out rectangle, which is 2 pi ROH, plus 2 pi r squared, because the area of a circle is pi r squared. 2 of that area will be multiplying by 2 to give you 2 pi r squared. We can carry out factorization. We now have 2 pi r into h plus r. This is a simplified form of the total surface area of a cylinder. Roman figure 2, we can also talk about the total surface area for an open cylinder. In the first case I have considered, the cylinder is closed. It's just like you buy a cup of milk or peak milk specifically, and then when you buy it, you have not opened it, you have not punched anything on it, the top is closed, the bottom is closed. Good, that is the first case. But assuming you now open the top after you have drank the milk, and maybe you want to convert the cup to do something else, so you can open only the top. So the base is closed and the curved surface is there, but the top is already open. In such a case, the total surface area for an open cylinder will be equal to 2 pi rho h plus pi rho square. Pi rho square because only one circular face is remaining, which you can also factorize to give you pi rho into 2h plus rho. Then C, we talk about the volume of a cylinder. The volume of a cylinder. The volume of the cylinder is the base area times the height. And our base area here, which is circular surface, is pi rho squared times the height, which is h. And multiplying them together, you have pi rho squared h. Usually, the pi is a constant, which we all know, can be given to you as 22/7 or 3.142 or whatever. Rho and h are not constants. They vary depending on the size of the cylinder. The next one is sphere and hemisphere. Here is a diagram representing a sphere. You can see that this is the center, and then this is radius, and that is radius. An example of a sphere is the earth's surface, and of course the football that you commonly see at home or in your school. So a football is an example of a sphere. Under the sphere we have the area, and the area of a sphere is 4 pi rho squared, which means 4 times the area of a circle. B, the volume, is 4/3 pi rho cube. With this formula, you can find the area of a sphere and also find the volume of a sphere. For the hemisphere, which is half of a sphere, half of a sphere. In most cases, we see this example in bows, some of the bows that we use in our daily activities. Now, this hemisphere has the center, the radius as indicated. To find the curved surface area, it will be 2 pi rho squared, half of the curved surface area of a sphere. B, the total surface area will be 3 pi rho cube, and while the volume is half of the sphere, which is 2/3 pi rho cube. With this formula, you can also find the volume, the total surface area, and the curved surface area of a hemisphere. We now look at another solid, a cone. Here is a description of a cone. You see that it has a radius at the base, and the base is a circular face. Then you have the curved body that looks like a V shape, and then you have the point here as the vertical point. You have the height represented by H here. You have another height represented by L here. Then you also have the angle at the vertical point. The height versus the angle at the vertical point. That is why I've written here alpha and also written here alpha. They are equal angles because the height versus the vertical angle. Let us explain what the letters I have used now mean. V stands for the vertical point of the cone. H stands for the vertical height. And YL stands for the slant height. So there are two heights. One vertical, the other one is slant. Then R is the base radius of the cone. Alpha is half vertical angle. And then 2 alpha is vertical angle. The 2 alpha, that is alpha plus alpha is 2 alpha, that gives you the vertical angle. I'm saying this because some questions will require you to calculate the vertical angle. You will first of all be able to calculate the first one, the alpha, and then multiply your alpha by 2 to give you the vertical angle. Take note of that. Now, we also look at the curved surface area of the cone. This is pi ROL. Pi ROL is the formula you use to calculate the curved surface area. The curved surface is the body without the circular base. The total surface area will now be pi ROL plus pi RO square, which means the curved surface area plus the circular base. This can be factorized to have pi RO into L plus R. C part of the cone, the volume, is equal to 1 over 3 times base area times height. This simplifies to 1 over 3 pi RO squared H. Because the base area of a cone is pi RO squared, it's a circular space. Note, using Pythagoras rule, our L squared is equal to RO squared plus H squared. And using trigonometrical ratios, our sin alpha is equal to R over L, and cos alpha is equal to H over L, and tan alpha is equal to R over L. You will recall the mnemonic SOHCAHTOA. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Another solid we shall consider is the pyramid. The pyramid here is described in this diagram. This particular pyramid is a rectangular pyramid because the base is a rectangle. So this is a rectangular base pyramid. When you say a pyramid is a right pyramid, it means that that pyramid is not distorted, is not biased in any form. It is a right pyramid, a correct and appropriate pyramid, not distorted. Now, because in most cases you come across questions where we have asked a right pyramid of so dimension. Now, if you look at this diagram, you have A, B, C, D as the base, rectangular base. You have the point B, which is the vertical point, where all the lines, the edges meet at that point. And now, this is the vertical height, and this is the center. Usually, we are more concerned with the calculation of the volume of a pyramid. And the volume here is 1 over 3 times base area times height. Looking at this specific one, the base area is AD times AB, or you can have it as BC times CD. They will give you the same result. Times OB, where OB is the height of the pyramid. As I said, we can also be made to calculate the total area of this pyramid. We can do that. In our subsequent lectures, we shall look at how to calculate the total area or surface area of a pyramid. Examples. Number 1. If the heights of two circular cylinders are in the ratio 2 to 3 and their base radii are in the ratio 9 to 8, what is the ratio of their volume? Option A, 27 to 32, B, 27 to 23, C, 23 to 32, D, 21 to 27. Our solution? Now, if you take a look at this, we are giving the ratio of the height. So the height is in the ratio 2 to 3. So let's say this is equal to 2K command and 3K, the actual value, because it's in the ratio, the simplest form. So assuming now that the actual value is 2K and 3K. And then we also have the radii is in 9 to 8. So let's assume now that this is equal to, let's say 9m, and then we have 8m, as they are also given in ratio. So we can now find the volume of cylinder 1, let's call it so. The volume of cylinder 1 will be equal to, remember the formula is pi r square h. So we have pi, which is a constant, multiply this by the radius. The first one is 9 meters, 9m squared, not meters actually. Then times the h, and the h of this one is 2k. Alright, then we take the volume of the second cylinder, cylinder 2, the same power, and then of course the radius is 8m, we square this, and then the height is 3k. So we are now interested in the ratio of, find the ratio of their volume. Ratio of their volume will be equal to, the first one is pi into 81m squared into 2k, all over pi into 64m squared into 3k. K, of course, we cancel k. M squared, we cancel m squared. Pi, we cancel pi. You are left with 81 times 2. 81 times 2 all over 64 times 3. And this will reduce to 2, we cancel this, 32. 3, we cancel that, will be 2 into 21 is 7. And then 2, we cancel this to give you 32. So the final answer is 27:32. And that gives you the answer as option A. Option A. Example number 2. The cylindrical tank has a capacity of 3080 meters cubed. What is the depth of the tank if the diameter of each base is 14 meters? Our solution. Here we are required to find the depth. And depth here, as I told you earlier, can also be represented with height. And so let's say this is equal to our D. Then of course we are told here that the diameter is 14. So the radius will be equal to 14 all over 2, and that is 7 meters. Again, we are given the volume or the capacity. Capacity is what it contains. Alright, and this is 3080 meters cubed. The same formula that you use to find the volume is what we also use to find the capacity. So our capacity here will be equal to, so capacity will be equal to pi radius square times height, which now becomes pi radius square times d. So what is the capacity? 3080. And then what is our power? In this case, our power, we are going to use 22/7, and our radius is given to us as 7 times 7, and then d is unknown. So we will now make d the subject of this equation. So your d will now be equal to 7 times 3080, and everything here will be divided by 22 times 7 times 7. And of course, what will this give to you? When you now cancel out, your answer will be 20 meters. 20 meters. So that is the depth of the water in that particular cylindrical tank. Example number 3. Here is a diagram describing a solid. What is the volume of the regular 3-dimensional figure drawn above? Options A, 160 centimeters cubed, B, 48 centimeters cubed, C, 96 centimeters cubed, and D, 128 centimeters cubed. Our solution. Observe here that the length of this solid is actually a triangular base prism. This is a triangular base prism. Triangular based prism. Alright. Now that we know what the solid is, to find the volume, we have the base area or the cross-sectional area. So let's use the word cross-sectional instead of base. So we have the cross-sectional area. Multiply this by the length. Multiply this by the length of the prism. Now, how do we get the cross-sectional area? If you look at it carefully, we have a right-angled triangle there at the cross-sectional face or surface. Now, this is 5 units, this is 4 units. So you can find your S. And from Pythagoras rule, your S will be equal to 5 squared minus 4 squared and everything under square root, and that will eventually give you 3. So, to find the area, we now have that this will be equal to half of the base, which is 4, times the height, which is 3. Multiply this by the length, which is 8. And when you do this, you have 2 times 3, 6. 6 times 8 is 48, and this is in centimeters cubed. Option B is the correct answer. Take note of how I have found the height of that triangle by bringing out the right angle triangle and then using Pythagoras theorem to find the height. Example number 4. A right circular cone has a base radius r centimeters and a vertical angle 2y degrees. The height of the cone is dash. A. R tan y degrees centimeters. B. R sin y degrees centimeters. C. R cot y degrees centimeters. D. R cos y degrees centimeters. Our solution. Now let's take a look at it. It's a right circular cone. Let me sketch a cone. Let's sketch a cone. Alright. And this is the vertical height. And this is the radius. And the perpendicular. Alright. And then we have that the vertical angle is 2y. So each of the angles will be y. And this one is also y, degrees. Now with this sketch, you will recall that from what we have, if you take a look at this, you bring out the triangle. This is your h, your y degrees, and then your r. Using the trig ratios, you have here that using trig ratios, trig for trigonometry, we have that r all over h is equal to the tangent of the angle y. Or we can say h all over r is equal to cot y degrees. Therefore, our h is equal to r cot y degrees. And then in centimeters. Option C is the correct solution. Remember that cot y is the reciprocal of tan y. So we now write this. The reciprocal of r over h is h over r, and the reciprocal of tan y is cot y. You cross multiply, your h is equal to r cot y degrees centimeters. Example number 5. Find the radius of a sphere whose surface area is 154 centimeters squared. Take your part to be 22 over 7. You have option A 7 centimeters, B 3.5 centimeters, C 3.00 centimeters, D 1.75 centimeters. 1.75 centimeters. Our solution, we are told to find the radius of a sphere, and the surface area is given to us. So the surface area of a sphere is 4 pi r squared. And if the area is 154, and that will be equal to 4 times 22 over 7 times r squared. We can now make r squared the subject of the formula, and that is 7 times 154 all over 2 times 22. This will give you 7 times 7 all over 4. Now, to find our r, you take the square root of 7 times 7 all over 4. And that is 7 all over 2. And that is 3.50 centimeters. And the correct option there is option B, and the correct answer.